Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. Leave us a review on iTunes to help other people find the show, send us a tweet, send us an email, leave us a message on Google+, or leave a comment on our show notes. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. I would also like to thank Hired, a job marketplace for developers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Linode is also sponsoring us this week. Check them out at linode.com/podcastinit and get a $10 credit to try out their fast and reliable Linux virtual servers for your next project. We are recording today on November 23rd, 2015, and your hosts as usual are Tobias Macy and Chris Patty. Today we are interviewing Sylvain Thénault about Asteroid. Sylvain, could you please introduce yourself?
Yes, sure. Hello, so my name is Sylvain. I have been working with Python since for the last 15 years almost, mainly at Logilab, where I'm doing some various client stuff, and mostly with Python.
So how'd you get introduced to Python?
I get introduced to Python, as I said, almost 15 years ago. At that time, it was Python 1.5.2. At that time, I began my internship at Logilab. And Python was the language of choice there. So I started to learn Python at this occasion. And as an intern, my first open source project was XMLDiff. It was already some things related to manipulating tree. It was about implementing some algorithm to indicate the difference between two different XML documents.
Can you explain what an abstract syntax tree is and why it's a useful language feature?
I can try to do that. Well, an abstract syntax tree is a representation of the source code. There are actually two different kind of representation. There are the abstract syntax tree and the parse tree. Parse tree I acquired. Well, the difference is that abstract syntax tree doesn't include every element of the source code, like parent or things like that. Spaces around operator or stuff like that. So that's why it's kind of an higher level. So in those trees, you get a representation of the structure of the source code. Each node of the tree is a construct that occurs in the source code, like an assignment. You get child nodes, one for the part which is assigned to, and another for the value which is assigned, etc. So you get a lot of different kind of node for every kind of construction you can have in your source code. It's useful for different things, like basically when you want to do almost anything with source code, you don't want to start from the string representation of the source code. So you start by having a tokenizer which feeds a grammar, and from that you usually get this kind of representation, and from that you can do almost what you want with it, like generating bytecodes or some source code, transformed source code, or doing some static analysis like we do in PyLint.
What was your inspiration for creating Asteroid?
I didn't need really inspiration because I have not started this project from scratch. When I started with PyLint, from which Asteroid come, it was in 2003, and we had a need for this kind of tool at Logilab where I wanted to check different things on Python code. At this time, I was only a PyChecker. And the problem with PyChecker was that it was importing the source code. So I wanted to do something that doesn't import. Because when you import the source code, for instance, you need to have all the requirements installed on your computer, and you don't necessarily want to do that. So I wanted to work on the source code, and at that time there was the compiler package in the Python Standard library. So I started from that. It wasn't at that time it wasn't named Asteroid, but Logilab AST MG. And so it was basically an extension to the compiler module. So that's really not a project that started from scratch. It started from this module, then it was adapted to as Python evolved. For instance, in Python 2.5, it was the beginning of the exposition of the internal abstract syntax tree of Python through the _AST module. So at this time we had to, it's really at this time that Asteroid began to have, I don't know how to do that, a kind of mixed AST, which was partially inspired from compiler module and from the internal abstract syntax tree provided by Python, which was of course different. Would be too easy. So it then evolved, but in any case, for instance, Asteroid doesn't include its own parser. At that time, it was either using, depending on the Python version you was using, it was using either the compiler module or the _AST module, but it was providing to the end user compatible representation.
Interesting. So what features does Asteroid offer over Python Standard Ast Package, and what makes those features important?
So beside the kind of compatibility layer, I may say a bit more about that later, but this is basically driven, Asteroid is driven by the PyLint's need. So the kind of thing you will find is like some more advanced way to navigate in the tree. Like you see some variable and you want to know which assignments node have affected this variable. That's kind of name lookup, but quite different. And the really main feature is like is static inference, which based on this name resolution is capable of answering question like what's the value of this variable, and it's based on simply by analyzing the static code. That's the big difficulty where there is no actual execution of the code. It tries to find what's the type or even the value of identifier or class member, instance member, and so on. Based on it's implemented using Python generators, because of course you may find several solutions. And so you've got an API where you just ask infer me every possible values, and it will return you things like classes, instances, list, constant values, and maybe a special kind of object saying that it has reached a path where he couldn't find any answer. So that's really the big thing you've got in Asteroid.
Just so that I understand, I guess I had thought with a standard AST, that's how they worked as well, that the AST would contain things like when you defined a class, it would contain the class definition with all of the methods underneath that expressed as method objects with statement object. You know what I mean? Like, I guess I thought it was broken down that way.
Yes, it is.
So, but you're saying that Asteroid allows you to infer the values.
Yes, I do. So you're right that in AST you get some, when you read some Python source code, you will get like a node for a function def or class def, and a node for every assignment there or any method definition inside a class def. And so it's quite low level, and you've got and you don't have anything like give me which the value of this attribute or this value of the value of this identifier at this point in the code. You basically only have nodes, and in Asteroid we have this inference capability, which by jumping from node to node is able to get back to you with, here are the list of value I've been able to find by analyzing the code statically. For instance, if you have, let's say, an identifier which is affected to a function call, then it's able to, it will look up by navigating in the tree what's this function. It may be a function, let's say, that is imported from another module. Then it will get the AST for this module, and it will look at the function and look at, for instance, the different values which are returned by this function, and it will get back to the caller that you may, by calling this function, you may get, I don't know, a list of ints, for instance.
I see. I get it now. So basically, Asteroid almost gives you IDE-like functionality in the API where you can say, what is the value here? Now, what is the value here? Now, what is the value here? As opposed to the standard AST features where it's just node soup, almost as if you were parsing an XML document or something with all the nodes that you have to walk and traverse to get the values.
Yeah, exactly.
That's interesting.
And that's quite complicated stuff with, basically you almost have to rewrite a kind of Python interpreter, because you've got to understand most of Python construct, like, I don't know, a tuple assignment or subscription, callable protocol. So we have to rebuild this kind of thing. So of course we have chosen to not using the interpreter, because using the interpreter would mean that the code would have to be executed. We are not executing the code. We are only partially almost executing it, but only by small bit, like I'm at this point in the code, and then it will provide some API to get every information you would get as a programmer by following the path, reading the function, look at the values which are returned, and things like that.
Yeah, it definitely sounds as though Asteroid would be the preferred way of interacting with the AST when you're trying to infer anything about the mechanics of the program rather than having to do all of the walking of the tree yourself. I'm curious if there are any sort of higher level graph algorithms that you leverage for that capability as opposed to just doing a brute force approach.
Yeah, that's the kind of thing we need in PyLint for static analysis. Like, you want to know this kind of thing because you want to check, for instance, that's pretty similar to the things you need in IDEA. In a static analysis tool like PyLint, you have similar needs as in IDE, because you want to know, if you are somewhere in your source code, you want to know that this self thing or this variable is actually some int or some instance of this class. And so you want to, in the case of an ID, you want to know, for instance, provide a completion or things like that to the user. In the case of PyLint, you want to check that it actually has the method that is used, or that this method or function has the correct arguments, and so on. Or maybe you don't mix string with int, and there is an infinity of things you may want to do with this kind of capabilities.
And so it sounds like with Asteroid and PyLint, you have at least some capability of doing type inference to determine if you're trying to do an incompatible assignment or access of various typing. And also I'm curious if the recent addition of the typing module to Python 3.5 is going to be a boon for your purposes in that respect.
Yeah, we are not currently, we are not yet capable of getting advantages during using type annotation we get in Python 3, but at some point we definitely will.
And so I know that the Asteroid package is used in PyLint, which is also maintained by Logilab. How does the AST facilitate static analysis of Python projects in other cases when you have to fall back to doing text parsing?
So first, to be clear, Logilab has created PyLint and Asteroid back in 2003. We have maintained it for almost from until now, but there are now several people in the boat with us, which are actually doing the most of the work. Like there has been some people from Google, which I've been involved in PyLint since for maybe 5 years now. It was the first important contributors we get. For 2 years now, we have another people which is actively maintaining PyLint and Asteroid. And we have now some new guy which is working particularly on Asteroid because he wants to use it in another project which is named MacroPy, which I don't know well, but attempts to provide macro for Python. So we are not the only maintainers now. A lot of some very active people, and I think that that's very good both for PyLint and Asteroid, since it's almost never. Both projects have never been so active as they are now. So to get back to the question, it provides some nice facilities like high-level representation of the source code. So we already talked a bit about that. In the case of Python, it's also a way to get a compatible representation, whatever the Python version. We used to provide support for something like Python from 2.1 or 2.2 to 2.6. No, PyLint itself is running, and even Asteroid is only running using Python 2.set because it's a way to have a code which is compatible using both Python 2 and Python 3, but you can still parse some code which is written for all the Python version. So Asteroid provide this compatibility level. And one of the main points is that it's generic to AST, is that once you get this representation, you can process it through a well-known design pattern, namely the visitor design pattern. So it's something which, I don't know if I have to explain this, but...
We can just add a link to it in the notes.
So this is a quite easy design pattern which allows you to do really different things. PyLint is using it for annotating the source code and maybe emitting messages, or you will see a similar thing in compiler if you want to generate some more advanced representation for your source code, if you want to generate binary stuff or things like that. So this is what you can do with an AST, but there are some things like where you don't have, you have lost information in the AST, so we indeed have to go back to text parsing. For instance, if you want to, in the case of static analysis, if you want to take a look at what's in the comment, or in comments you don't have, you have lost comment in the AST, or if you want to, for instance, check that you have like a PEP8 checker, almost you can do anything with an AST because you will be interested in line length or spaces around operators, things like that. So you have some time to fall back in such case to text parsing. We do that in PyLint. Actually, in PyLint we have even 3 kind of checkers. One working on the AST using a visitor pattern. You may also provide some checker which will work at the token level using the tokenized module of Python Standard Library, or directly on the file using a line stream. For instance, in case of for the tokenized module, we recently wanted to add a check that if you are writing if, else, if, another condition, in some case you may want to rewrite it. You may be able to rewrite it using a single if, elif construction. You see what I mean?
Mm-hmm.
So in the case of abstract syntax tree, in the Python abstract syntax tree, it already, if you have in your source code if, elif something, you will have in the abstract syntax tree if, else, with a child if, else node in the else branch of the first if. You see? So it's not, if you just write it back to Python, you won't get the exact same thing as the one which you have been parsing. So in this case, that's an example where we had to take a look at the output of the tokenizer to see, to distinguish between if node which are actually if node, or if node which have been introduced by the parser but which are actually elif part of a previous if. And so that's an example where we have to get back to tokenize, and I think I've already mentioned cases where we have to go back to text parsing for like commas, spaces, and almost everything which is in the PEP 8.
Yeah, I can definitely see where text parsing wouldn't, or where the AST wouldn't provide the full suite of information that you would need to do proper analysis of Python code for code quality and sort of stylistic checks as well. So,
yeah, you even don't have, for instance, a parent, which are used to balance expression.
Mm-hmm.
So this is, you don't know if there are or there are not parent in the original source code. So without extra information, you can't, from the AST, you are not able to reproduce the original source code. That's where you will have to jump to other representation like parse-tree.
well, I have to say that having a greater understanding of the mechanisms that are going on under the covers when using PyLint, I'm very grateful for all of the hard work that you and everyone else has put into it to make my life easier for determining where I'm doing things wrong in my code.
Thanks.
And so, beyond static analysis, what are some of the other possible uses for the Python AST and the Asteroid library?
Yes, as I said, there is a guy now hardly working on Asteroid, which intends to make it a reference implementation of AST for Python, because it, as I said, it was extracted from PyLint a long time ago with the intent that it may be used by other projects, but as it was mainly driven by PyLint needs, the API wasn't as clear as it should be. But I think it provides enough nice features to be attractive. So this guy decided to make it clean and make it at some point to make it more powerful and to use it for this MicroPy project. You can also, I don't know, maybe generate documentation, or the AST is also used for for instance, doing things like 223. Like reading Python 2 code and generating Python 3 code, but in this case, it's not using the same base implementation as we are using, because we already say that you lose some information that you don't want to lose if you are transforming your source code from Python 2 to Python 3. You maybe won't be very happy if you lose all your comments and formatting on the way. You can also maybe do some kind of code completion. We already talked about using it in IDE. Things like that. I've made some, a long time ago, I made a toy that was allowing you to display your source code in HTML, and then you could click on every variable and it was jumping to the place where it was defined in your source code. It was the kind of thing you may want to do.
That sounds like a very interesting project.
It's a dead project. It was only, it was something I've done in EuroPython 5 lightning talk. But I have not. I don't even know where the source code is now.
Well, it's just another example of where whimsy in programming can lead to some pretty interesting outcomes.
Yeah.
I know that there are a few other projects I've come across recently that leverage the AST to some pretty interesting effect, such as a little while ago we interviewed the folks behind the high-laying implementation of running a Lisp dialect on top of the Python VM. They said that they use the AST, and there's also the Pony ORM, which uses the AST to allow you to write SQL expressions using Python list comprehensions and generator expressions. So the documentation for the AST package in Python mentions that the specific syntax objects in the tree are subject to change between releases, and I'm wondering if the Asteroid package provides any abstractions to maintain a consistent API between different Python versions, or does it just provide a pass-through for those syntax objects and adds the extra metadata around and convenience methods around the tree itself?
Yes, it does this kind of thing. Actually, it always starts from the Python representation. So it uses the Python parser, but from the AST, which is written by the Python parser, you've got afterwards a rebuild step, that will kind of normalize this Python tree, so it's compatible with when there is some change across Python version. So you may expect to have always the same representation. That's actually a basic need for tools like PyLint, where you want a single PyLint. You don't want to handle every case of Python version. Also, it provides, for instance, when a new Python release introduce some new nodes, because there are some new constructs in the grammar. Usually you may import them from Asteroid, even if you are using a lower version. So that's a kind of consistent API, and that doesn't mean we don't want to make it moving. It evolves as all API, but we are trying to do it in a proper way with some kind of deprecation for some time. Like if you are using the old API, it will still work, but with a deprecation warning, which usually explain which new method or function or class you should use. So, because of course we don't have the same constraint as Python, and that's a kind of service which is provided by Asteroid.
Have you encountered any challenges in testing Asteroid, given that it operates at such a low level in the language?
Well, not really in testing. However, there are some tricky stuff in Asteroid, because a feature I forgot to mention is that Asteroid provides AST representation for objects which don't have source code, like built-ins or objects which are implemented in C extension, or even Python code where source code isn't distributed. So it's very useful. Like you may want to, in some case, for instance, in PyLint, we don't want to have special way to understand either Python source code or code which is coming from built-ins. We want to be able to handle them similarly, and also it's very useful. It's almost a need if you want to do some kind of static inference. You don't want two different representation. You have to share the same kind of representation. Whether you see that I don't know, you have a list defined in your Python source code, or whether you have some kind of built-in function which return a list or things like that. So that's somewhat a bit tricky. For instance, you have to bootstrap the Asteroid packages, the Asteroid representation, using by building some representation for everything that is in the built-in module in Python. You need to do that in a specific time because it does some advanced stuff. And for instance, when it's building an AST, it will itself use its own inference capabilities to add some information to this AST. So it's a bit tricky to bootstrap the process. I think that's the kind of thing which also makes Asteroid different from other projects.
So speaking of Asteroid being different from other projects, do you have trouble getting contributors given the great understanding of Python's inner workings required?
Maybe. We have been working on PyLint and Asteroid without much contributors for years, but I think there's a fairly good ecosystem in Python. I don't know if you are aware of the code quality mailing list, which is about code quality in general in Python, of course, and where you will find people which are involved in Pep 8, Flake 8, PyLint, and other tools like that. So you have some people which are, I think, advanced Python user and quite good computer scientists. So there are not a lot of people, but that's pretty good people, and we currently have maybe 3 people working on Asteroid or PyLint. But if you take a look at the Bitbucket projects, since both are hosted at Bitbucket for now, you will see that it's very, very active. So I can't say that it's a trouble.
And so does the implementation or representation of the AST differ between different distributions of Python, such as CPython, PyPy, and Jython?
No, this is the AST is representing the Python language, and it should be, so there is different version of the language, but that's the like Python 2 or Python 3, or maybe you've got different constructs in Python 2.5 and Python 3.2. Provided that you are comparing CPython 2.7 and PyPy 2.7, it should be the same AST, and Asteroid should be able to work with any Python implementation.
I guess that's another benefit of having such a well-specified language definition as opposed to some of the other languages that have alternate implementations, such as Ruby.
Yes, indeed.
So what are some of the most interesting applications Asteroid has been used in?
As I said, Asteroid has been designed to be used in other projects, but until now it was kind of failed, probably because of various reasons, like I mentioned, like maybe there was a bit of technical debt. The API has grown and needed to be refreshed. And also there are a few projects that really need this kind of thing. So PyLint is definitely the easy user in the place. I think that it will probably change in the near future, like, because there is heavy lifting, which is being done currently by contributors. So I hope the best is still to come.
So before we move to the picks, are there any questions that we didn't ask that you think we should have, or anything that you would like to add?
No, that's fine by me.
Okay. All right, so I guess with that, we will move to the picks. And for my first pick today, I'm going to choose the pre-commit framework by the folks at Yelp. I just added this to my projects at work, and it's a library or framework that lets you easily add and specify pre-commit hooks to run on your project, and it supports multiple languages. So built in, they have the ability to do hooks that are written with Python, Ruby, Node, as well as general scripts or system binaries. So I actually just added a pull request to it recently for being able to specify additional dependencies so that you don't have to go and rewrite a module for it just to add some extra plugins. Like most specifically, in my case, was for ESLint. So definitely pretty useful. I recommend checking it out so that you can add some pre-commit checks for doing static analysis and executing your tests before you actually push it up to your repos. For my next pick, I'm going to pick an online comic called Existential Comics, and these are all pretty funny treatments of different schools of philosophy. And so the one most recently is a comic of various philosophers taking part in the storyline of Monty Python's Holy Grail. So I can't even begin to do it justice by explanation, so I recommend you just go check it out. And my last pick is a project I came across recently called HTMLPy, which seems to be taking a page out of the playbook of the different Node-based desktop apps that have been coming out recently that are leveraging web technologies for making it easy for different people to create desktop GUI apps. And so this is an application that lets you use HTML5 and CSS3 for defining some of the UI of your program, and then it uses PyQt under the covers to provide the frame as well as being able to provide back-end logic in Python. So pretty interesting, and I'm definitely happy to see that as a new entrant into the Python GUI ecosystem and as a way to help move forward desktop applications beyond what we currently have available and to maybe bring in some people from the web community to provide beautiful looking UIs to Python programs. And with that, I will pass it to you, Chris.
Very cool. I'm going to keep my picks relatively short this week because I have a hard stop. But I have two. The first is a beer. It is the Pretty Things Brewery Fluffy White Rabbits. It is a really great triple with a fluffy mouthfeel, as they say, which I know sounds kind of strange, but it's true, and a really nice fruity character. And Pretty Things is ceasing production, so Boston area beer fans are sad. And my next pick is a game. If you're a gamer, you've already heard about this, but oh my god, Fallout 4 is really impressive. Since it's set in the Boston area, as a longtime Bostonian, I am kind of blown away, even by things like the detail of the trees and the grass. It looks like trees and grass look like here, which I realize is a small thing, but it's kind of makes the whole experience even more surreal, like you're actually wandering around in an area that you know well. Great stuff. Sylvain, what do you have for us for picks?
I have two picks, which are mainly things I have also worked on. My first one would be PyReverse. It may be good to know that this tool is distributed with PyLint, and it's a nice thing to do some quick reverse engineering, like you just start PyReverse on your project and it will be able to produce a class diagram or package diagram for the whole project, or you can say give me a diagram for this class with maybe all the classes which are related to jumps around and things like that. So it's pretty nice, and I think it's a good way to stop maybe doing too much UML diagram when in a specification phase. Just write your Python code and get the diagram afterwards. So that's was my first pick. The other is another project on which I have been very involved and which is mainly developed at Logilab. Is the Cubic web framework. So that's a web framework for Python, which is quite at a higher level than Django or Pyramid or Flask or usual Python web framework. And it's heavily relying on the principle of the semantic web, like every object there has an URL, and it attempts to write to expose your data using known vocabularies such as FOF or anything. So you just start up with a schema. You've got a working application, and then you can put some data there and apply some view to your data. So it's a different way to build your web application, which is very incremental. So you can build application with a lot of agility, and I think it deserves a look.
Okay, so I really appreciate you taking the time out of your evening to join us today to talk about Asteroid and some PyLint. And for anybody who wants to keep in touch with you and follow what you're up to, what would be the best way for them to do that?
Well, you can, for people which are interested in Asteroid or in PyLint, I highly recommend to register to the code quality mailing list. There is also the PyLint dev mailing list for people which are more interested in contributing or with a more technical question. I'm on Twitter at Thénault, Sythenault. My name is a bit complicated. And of course, you can follow our work at Logilab on our logilab.org website or cubicweb.org website, or Twitter at Logilab.
Excellent. Well, thank you again, and I hope you enjoy the rest of your evening.
Thank you for receiving me.
Thanks.
Bye.
Bye-bye.
Bye-bye. Ciao.